Hi everybody, it's Miss Phoebus, and this is Lesson 12, Domain and Range and Function Notation. This is two kind of mini lessons that I've stitched together in one. They kind of go well with each other, so I just wanted to let you know that it will feel like we end something and go into something different, where we are going to look at identifying domain and range of a function or a relation, and then I can evaluate functions written in function notation for a given value of x. So again, two kind of separate ideas, but usually they piggyback pretty well with each other. All right, our state standard, basically the one from yesterday, we are getting to know domain and range and how they're connected to each other and if something is a function. But then we're going to also look at function notation, evaluating functions for inputs in their domain, and looking at those types of things as well. So I'm going to have you pause the video and figure out a way to define this. If you can try to do it from memory, great. All right, so domain are all the x values or the inputs of a function or relation. So if you wrote down domain as x values or inputs, excellent. The range are all the y values or outputs of a relation or function. So all of those things are important vocabulary words that you need to know, domain and range. And we're going to be identifying those today. So what we want to do, and if you can remember back to the video from yesterday, is that we want to look to see, do we have any repeating x's? So I'm going to check all my x's and see if I have any repeats. So I have 2, 6, 4, 5, and -8. No repeats at all. So we're looking good. Is it a function? Yes. Why? Because each x has only one y. That's like my canned response. Now, some people are going to want to say, because it passes the vertical line test. But unless you're graphing it, you don't know it passes the vertical line test. So because each x has only one y, perfect response to this. All right, domain. So when we write domain, we're going to write all the x values, but we're going to make sure, I want you to maybe make note of this, no repeats when writing domain or range. Okay, if you have a repeat that happens, you only write it one time. Now, some people argue you should write from least to greatest. I don't care about that. I just want everybody present, but only one time. So we've got 2, 6, 4, 5, and -8. Now, just like our relation is kind of grouped in these curly brackets, we're going to do the same thing. So you can practice these. Now, these take lots and lots of practice, and some people don't believe me until they try to make it. Sometimes my kids do this, and I understand what you're doing. If we ever get back and I'm giving you paper assignments and I'm having you write these things down, you may see me go like this and try to help you out so you can see it. But something there so that you can see, where does the domain begin, where does it end. Some people use parentheses. That's okay. It just looks like a really big order pair. I guess it's not an order pair. But, you know, something to show it begins here, it ends here. All right, let's look at range. Range are all the y values. So I'm looking for repeats. -4, -2. Okay, you see there? There's another -2. I'm only going to write -2 one time. No repeats. There's another -4. I'm only going to write -4 one time. No repeats. And then there's -6. So I'm going to have -4, -2, -6, and I'm going to trying to get you to do these little curly braces. Braces, brackets, I don't know. But that's how good mathematicians write their domain and range. All right, so let's look at number 2. Is it a function? So we're checking x's. Do x's repeat? -4, 5, 4, -6, 4. Okay, there's another 4, a second 4. So is it a function? No. Now, For the y, you could say because each x doesn't have only one y, but I like to really blame who is causing the problem, so I would say because 4 repeats. So sorry for I'm calling you out on your nonsense there, but it really makes sense if you can identify where the problem is. Because if you say because 4 repeats, and I look at the problem, I'm like, 4's not repeating. Oh, maybe they think a -4 and a +4 are the same thing, or something like that. So I really do like calling out the offender. I guess that's really what it is. So when I write my domain, I'm going to make sure I only write 4 one time. Now, -4 is a different number. -4, 5, 4, -6, no repeating that 4, close it up, you're done with the domain. Alright, range, go look at the y's. 6, 8, -7, -8, 7. I don't see any repeats. 6, 8, -7, -8, 7. Close up the range, and there you go. So, you're making a list. When you make a list, just like you're making a list of things in English, when you're writing a sentence, you put commas. You also need to put commas here, because in your domain, if you write -45, that looks like -45, and -45 is not in your domain. But if you put a comma between them, that's going to help. Now, if you go and you look at your Chromebook, next to P, the letter P, to the right of it, you have those curly braces. So you can hit Shift and then one of those buttons and do your beginning and end of your domain. So those should be pretty easy to get into Canvas. You shouldn't have to do math type unless you really, really want to. You make it look fancy. So the next ones are you try 3 and 4. Pause the video. Alright, so let's look and see. 3, is it a function? So I've got -7, -6, -4, -8. There's another -6. So it is not a function. Why? Because -6 repeats. Shame on you, -6. It's okay. Alright, domain. So do you have your little curly braces there? -7, -6, -4, -8. Do not put that other -6 down. Close it up. That's your domain. Now, let me show you. Maybe you did in the you try. Maybe you did put -6 there. What I want you to do, instead of erasing it and making it look like you never made that mistake, mark through it. So no repeats. Make sure you know why it's marked out. Make sure you know why it's not there. All right, let's look at range. -8. We've got another -8. We're not going to put it in there again. -6, -5, -4. So, -8, -6, -5, -4. Close up those curly braces. All right, let's look at number 4. 8, 4, 6, 7, 2. No repeats, so it is a function because each x has only one y. One y. All right, let's get our domain in there. So we have 8, 4, 6, 7, 2. You got your commas. You got your curly braces. All right, let's get our range in there. -2, -6, -8, 5, and 4. Somebody slammed the door. Shut my board. All right, -2, -6. I don't think I said any repeats. 5 and 4. There we go. Domain and range, X and Y values, making lists. All right, let's look at some different formats, kind of like what we looked at yesterday. All right, so here we have some mapping diagrams. Now, some people, they get really excited, especially on pencil paper homework, and they go, there's the domain, there's the range. And I'm like, no, that's like being lazy and cheating and that kind of stuff. So you're going to practice making the list, okay? Now, one thing that you can do to shorten and a little bit of college notation is we use bolded script to represent domain and range. So to make a domain, you draw two vertical bars and then turn that into a D. So that represents domain if you want to do shortcut, and you don't have to write this out. So if you don't want to write domain, you write D, and that means that you are abbreviating domain. Same thing for range. Two vertical bars, turn that into an R. That is range. So when you write these out, and I say list the domain and range, and you're going to use your little squiggly brackets on your keyboard, you're not going to need to write it like this per se, but you can write a capital D and then like a colon and then start your domain. You definitely want to label these. All right, so what we're going to do for functions, figure it out if it's a function, remember, with a mapping diagram, we're looking for one arrow leaving. If we have more than one arrow, not a function. So one arrow, one arrow, one arrow. Look, there's two arrows, not a function. Why? Because 3 repeats. Now, 3 only looks like it's there one time, but it's connected 3, 5, 3, 7. So that's what you've got to watch out for. Domain, you are just going to list everything in that input box. -4, -2, 0, 3. Okay? But just circling things, you're not going to be able to convey that to me enough. I want to see these lists of values. Same thing here for our range. I'm going to -3, 6, 3, 5, and 7. No repeats. That's the nice part about the mapping diagram. They don't allow repeats, so you pretty much are going to avoid that. Try number 6. See what you can do. All right, is this a function? So let's check. One arrow, one arrow, one arrow, one arrow. We're looking good. So is it a function? Yes, because each x has only one y. So that's the first thing. Domain 1, 2, 3, 4, because that is in the x portion. And then range. Now, some people might be concerned they aren't number values. That is true. But if you remember in the example yesterday, we had months of the year. We had days in those months. So January, February, March, April, those weren't numbers either. So we're going to have D, B, C. And there you go. Domain and range. All right, we're going to do a table and then a graph. And then we'll move on to our function notation. So I'm going to do 7, and then I'm going to get you started on 8, and then you can try to finish at 8. So we're looking at x's in the table. I don't see any repeats, so it is a function because each x has only one y. The domain is -2, 0, 4, 5, because those are all x values. And then you go to the y column. I don't see any repeats, so we can just write 14, 6, -10, -14. All right, now for these, what I like to do is I like to know what the order pair is. So this is -4, 1. And what I would do is I would encourage you to write down, there are 5 points, write down all 5 order pairs, and then I want you to go ahead and fill in that information. Is it a function, domain, range? Do that now. All right, so I'm going to finish these points, This is -1, comma 2. This one is 0, comma 1. This is 2, comma 3. And this is 3, comma 1. So if you don't know what the points are, or you're having to work really extra hard, sometimes that's easy to write it down, and then you're kind of doing what we were doing in the beginning, where you're just dealing with the order pairs. Is it a function? Yes, because I don't see any repeating x's, but this is also a graph. So I could say, because it passes the vertical line test. But if you are not graphing it, or you don't have access to a graph, don't use that. Each x has only one y is better. All right, let's look at our domain. I usually take my x's from left to right. So -4, comma -1, comma 0, comma 2, comma 3. And then let's look at our y values. I've got 1, 1, 1. So I have some repeats. I'm only going to write one time, one time, and then 2, and then 3. So 1, comma 2, comma 3. All right. So that is domain and range. Make sure if you're having any questions about any of this, I think that it's pretty straightforward, but maybe I said something that is confusing. So don't forget, you can send me an email. We can do a Google Meet. All you got to do is let me know. Let's look at function notation. And we're getting into some vocabulary, so some words that you may not know, you may know. Do you know evaluate? Do you know what function notation is? Evaluate can be used in two different ideas, and I think you've done both of these. So if I give you a string of numbers, that means I want you to, and tell you to evaluate it, I want you to use the order of operations. So to evaluate this, you would do 3 times 2, you would get 6, 6 plus 4, you would get 10. So your goal is to get a number answer by doing the order of operations. That's one meaning of the word evaluate. Another one is if I give you an equation or an expression, and then I ask you to plug in a value for a variable, can you do that, and can you come back to me with an answer? So either way, you're coming back with a numerical answer. It's just, do you have all the numbers to begin with, or are you having to replace some things? Now, one thing, I made a mistake on here that I want to change. Not really a mistake, but I left something out. And one of the things that I want to encourage you to do is I want you to wrap everything that you plug in parentheses. I want you to get in a good habit of that. I'll put my square there. Okay, parentheses are going to help protect your numbers. We're going to look at that in a second with the calculator. But if you do not get in good habit of putting parentheses around the numbers that you plug in, you may sometimes get the right answer, but sometimes get the wrong answer. And I don't want you to get the wrong answer because you're working hard on the math because you forgot something. So parentheses are really, really important. Now, you have access to a TI-84 graphing calculator on your Chromebook. You can get to it by clicking on the circle launcher where you go to find the camera, and if it doesn't come up with like a little button you can push, you can start typing in the little search TI, and then it should pop up. It's a TI-84 Plus Color Edition, so it's really nice, and it's free. Isn't that exciting? So let me show you the reason why parentheses are important to you. Now you got to be careful. The negative button is down by the enter. If you use the subtraction key, you're going to get a syntax error. Let me show you that. So I'm going to do parentheses, and I'm going to say the subtraction button is the negative. I'm going to close it, and I'm going to square it. And then the calculator is going to say syntax error because you told it you wanted to subtract 2, and it's like, I don't know what you want to subtract 2 from. So if I go to if I hit 2, it'll allow me to change that. So I don't want the subtraction, I want the negative. So the negative is down next to the enter, and it will give you the same error if you get that syntax error, you might want to double check that. So if I do -2 in parentheses squared, I get 4. Now, no parentheses, so -2, and then I'm just going to square it. Now, you have two options for squaring it. You got the little squared button here, but you can also use the little caret button. A lot of you know about the caret button. It doesn't really matter which one you use. But without the parentheses, I get a -4. So what's going on in your order of operations? For the first one, the only thing that's happening to it is the exponent. And the exponent says, hey, we're squaring -2. -2 times -2 is +4. In the second option, it's saying, okay, exponent first, and then multiply by the -1 in front of that. So 2 squared is 4. 4 times the -1 in front of it makes it -4. So if you are plugging things in, values, numbers, and you're not putting parentheses around them, you're going to possibly, I'm going to say possibly because it's possible not to do these things, not to plug it in and, or not to, it is possible not to use parentheses and get a correct answer. But I want you to have something that will work every single time. And so parentheses will work every single time. If you were doing like 3 times 2 squared and get an answer, you would have to, if you don't use parentheses, you would have to use the multiply button. You could still get the same answer. You're still having an extra symbol. So just kind of play around with it, see what you can do with it. You are allowed to use the calculator. Some of these you may end up realizing that your mental math skills are good enough to where you can kind of go through them and not need a calculator, but I did want to show you that you do have it available. We are going to get in and mess with it a whole lot more, especially in this lesson. So if you are having trouble, not in this lesson, in this unit, if you are having trouble accessing it, please let me know so I can help you out. Alright, I'm going to close out of it. If you want to pull it back up, you can. Goodbye. Alright, so the other thing is function notation. Function notation is a special notation that allows you to see the input and the output value at the same time. So that is something, I know that you can see it as an order pair, but this is a kind of, we're ramping it up a notch. And so we're looking at notation that the ACT and EOC could give you, even they use it a lot in calculus, that things are normally written in, that if you have never been exposed to it, you're going to not know what's going on. But that's my job. I'm showing you how to do it. Alright, so here is our first, see what changes have happened, see what's different, what's the same, that kind of stuff. Alright, if you notice in the first box we've replaced all the x's and we put in a heart. So we've got f of x equals x squared, that's how you read it, f of x equals x squared plus 3x minus 1 becomes f of heart equals heart squared plus 3 heart minus 1. So the only thing that I did was I didn't say x, I said heart instead. So it's like a substitution kind of thing. Take out the x, put in the heart. Same kind of thing for f of x. Here in the second box, we're replacing it with f of smiley face. Who does math with smiley faces? Me. I do math with smiley faces. I love math. Alright, so we've got absolute value of x cubed minus 2x. Because I come to an x, I replace it with something else. Everything else remains the same. Now in this last one, notice that I'm not just plugging in a 3, I'm also wrapping this 3 in parentheses. And if you see me not wrap my values in parentheses when I plug them in, just know, shame on me, bad habits. I'm trying to teach you guys good habits. So you should be plugging in values and wrapping them in parentheses, and that will help you in the long run. And this is something that you could type in the calculator. Not anything here that we could type in the calculator, but 2 times 3 squared plus 3 minus 1 is going to be something that you could get a number for and you could evaluate. All right, let's look at a graph. So here we have all of this notation. And the thing about this notation is that you are able to see an input and an output at the same time. You're able to see an x value and a y value. These are actually, believe it or not, order pairs. Okay, so I'm going to show you some things that might help. So the first thing I'm going to show you is f of x equals y. This is true. F of x always equals y, where x is the value on the inside of the parentheses. So there's an x, and there's an x, there's an x, and there's an x. The y is always after the equal sign. So here's a y, here's a y, here's a y, and here's a y. So all of these are order pairs. So the first one is negative 2, 4. The next one is negative 1, 3.5. And we have 0, 3, and 2, negative 1. And all of these order pairs correspond to this function right here. This is f of x. It is a function. It passes the vertical line test. And so these points, let's look at it. So negative 2, 4 is right there. Negative 1, 3.5, right there. 0, 3, right there. And then 2, negative 1, right there. These are all points on this function. And so this is just a fancy, scary way of trying to show you points that are on the function, whereas this is something that you guys have been doing for a long time. So it's like we're cranking it up a notch. We're trying to write it a little bit differently, a little bit more algebra to it. But we're also accessing something where somebody can write something in a more difficult way and we can read it. So you're really learning right now how to read the math. You know how to read words, and you've been reading words for a long time, and they're easy right now because you've been doing that for a long time. So if you feel confused about this, just remember you're learning to read math. Okay? So you'll be all right, I promise. Now, let's learn how to read what they want from us. So what is function notation? You're going to see f of x equals 2x, something like that. And remember that this is just the same as y. If I said y equals 2x, some of you would be like, ooh, I could graph that. Some of you would be like, well, what is x? If you give me x, I can give you y. Some of you would say, hey, if you tell me what y is, I can divide by 2 and solve for x. There's lots of things that you can do with that. So f of x, and y are interchangeable. So it's like we're getting a makeover on y, and now he's a little bit fancier. And this f represents the word function, but it's the name of the function. So if you look, we have a couple examples here. Here's f of x, but this one's a different name. This is g of x. We can have h of x. We can have m of x. We can have p of x. There's lots of different variations. Now, you will probably never see x of x or y of x. Those just kind of get a little weird. But the letter out in front is not a variable. It's the function's name. All right, this is going to tell you, this x inside, just like we had hearts and smiley faces, it's going to tell you what to input in for the variable x. And this is a place for you to put a number, to work it out, to take your number, in this case multiply by 2, and get a value. So let's do a little bit of these. Now, when we do these, I'm going to do the odds, and then I'm going to have you try the evens. So for number 1, there's not a whole lot of math we're going to do because we're plugging in a star. But as I go through the function f, everywhere I see an x, because there's a star in that location, I'm going to take out the x and I'm going to substitute in a star. So f of star would be how you read that, equals, And so this is what I'm working with. Negative 2. I'm about to write x, but I don't want to write x because this tells me every time you see an x, plug in a star. So I'm going to plug in a star plus 5. Now, some of you may say, well, what is negative 2 times star? Nothing. There's nothing I can do with it. It's just negative 2 star. But I just want you to get the idea of we're trading things out. So you're pulling out the x, you're replacing it with a star. If there's something you can do, do it. If there's nothing you can do, you're going to be okay. So let's look at number 3. We're still working with f of x. But instead of x this time, not a star, we're going to plug in a 3. So we'll have negative 2, and then I want you to wrap parentheses around that 3 plus 5. My plus looks like an and sign. All right, now you can't solve for f. This thing is like the function's name and what we plugged in. The only thing you can do is on the right-hand side. So we're going to multiply. Negative 2 times 3, negative 6, plus 5 is negative 1. So all you can do is simplify stuff on the right-hand side. I've had people that are trying to solve for f, and that's not going to work. This is x. This is y. And what we've done is we've figured out a point on the function f of x. So that's 1 point on it. You try 2 and 4. See what you get. Pause the video. All right, number 2. We're not using f. We are switching to g of x. So we're completely switching functions. So that's why they have different names, so that I can give you several different functions and you can know which one I'm talking about. Instead of x, we're going to replace every single x with a heart. When we do that, everything else stays the same about it. So I'm getting ready to write x squared, but I'm not going to write x. I'm going to write heart squared plus 2 times, don't write x, write heart, plus 3. Now, what is heart squared? I don't know what love squared is, but that's the best I can do. All right, let's look at f of negative 2. We're going to go back to our function that I have here in the green box. I'm going to replace x with negative 2. So I'm going to have negative 2, parentheses, negative 2. Look at your paper. Do you have parentheses? Plus 5. If you don't have parentheses, fix it. Okay, negative 2 times negative 2 is 4. 4 plus 5 is 9. So f of negative 2 equals 9. And this is the function notation. The nice thing about it is that I can see the input and the output at the same time. It is represented, I can represent it as an ordered pair, but really this is the answer that I'm looking for. Don't need the x and the y. But these are the same thing as far as if I was going to graph these points to build my function f of x. So I could draw a picture of f of x by looking at different points that make it up. All right, let's look at number 5. I'm going to do 5 and 7. You're going to do 6 and 8. So for number 5, I'm looking at function g, and then I'm going to replace that x with a 10. Everywhere I see x, I'm going to put it in parentheses. So I've got 10 squared plus 2 times 10 plus 3. So 10 squared is 100. 2 times 10 is 20. So when I put these together, g of 10 equals 100 plus 20 plus 3 is 123. So if I was looking at this being an x and this being a y, and I was going to graph this, 10, 123, wow, that's a big y value. That would be a point on function g of x. All right, let's look at the next one, number 7. F, I'm going to replace, in f of x, I'm going to replace the x with 5. So I'm going to have negative 2, put in parentheses, I'm plugging in negative 5 plus 5. Negative 2 times 5 is, negative 2 times negative 5 is 10, plus 5, so I get 15. So that's what f negative 5 is. There's my x, there's my y, So my order pair, if I was thinking about graphing, or I was thinking about domain and range, my domain is -5, my range is 15. So all of this stuff is connected. And so you can look at these as graphs, you can look at these as tables, you can look at these as equations. All of them are related. They all use domain, range, values of points, and all of that kind of stuff to, and it just kind of all pulls together. You try 6 and 8. All right, both of yours are with g of x, so you're going to be working with the one that has the x squared. We're going to plug in 0. 0 is my favorite thing to plug in. 0 squared plus 2 times 0 plus 3. So 0 squared is 0, 2 times 0 is 0. So I've got 0 plus 0 plus 3 is 3. G of 0. So if I was looking at this as a point, my domain is 0. My range is 3. 0, 3 is a point on that function. Let's look at g of -4. So I'm just going to keep using that, except I'm going to plug in -4 into g of x. So I'm going to make sure I have my parentheses. Do you have parentheses? All right. We're going to square -4 squared is 16. 2 times -4 is -8. Plus 3. 16 minus 8 is 8. 8 plus 3 is 11. So that is g of -4. There's your x, there's your y. So -4, 11 is a point on that function. All right. Let's look at 2 examples that look super hard, but are actually really easy. You might run across them on like an ACT test or in calculus, but it's not too bad. Again, personal fan. I am a personal fan of things that look terrible but are actually really easy. So think back to what we're doing. We're taking a function. In this case, we're taking function g, and everywhere there's an x, I'm going to replace it with an a. So in g of x, I have x squared. Well, I'm going to replace x with a squared. Plus 2 times x, so plus 2 times, don't write x, write a, plus 3. And that's it, that's all you can do. All they're telling you is to replace x with a. Not too bad. You try number 10. Alright, they're telling you to take function f and replace all the x's with w's. So -2. Take out the x, put in a w, plus 5. Now notice I didn't put parentheses around these variables because I am plugging them in, but I'm not able to do any math. I'm not plugging in number values. We're going to look at a few more examples, and then especially with the table and a graph, and then we'll be done. So with these examples, they are setting us up for trying to figure out, if I give you x, what is y? If I give you x, what is y? If I give you y, what is x? If I give you y, what is x? And then here, down here, we're comparing things. Same thing for the table, and then we're going to look at some graphs. So let's figure out what our values are. If they give me x is -1, I'm going to plug in -3 times -1 squared, and I'm going to go through the order of operations, or you plug it in the calculator. -1 squared is 1. 1 times -3 is -3. Let's do it again with 4. G of 4, we're going to have -3 times 4 squared. So let's go through our order of operations. 4 squared, 16. 16 times -3 is -48. Now, for the other ones where it's y equals, what we're going to do is we're going to do -3x squared equals -300. And we're going to start by dividing by -3 so that x squared equals 100. Can you think of a number that I can square and get 100? One number you can square is 10. There's actually another one. There's a negative 10. So I could have a positive 10 or a negative 10, but both of those, if I square 10, I get 100, and then if I multiply it times negative 3, I get negative 300. I'm going to erase this work so you don't get confused later on. Alright, let's do the same thing. Negative 3x squared equals 0. I'm going to divide by negative 3. What number squared equals 0? The only number I know squared is 0. So if I plug in a 0, do I get 0 into my equation? Absolutely. Alright, let's try the ones down here. We're going to plug in negative 2. So negative 3 times negative 2 squared. Well, negative 2 squared is 4. 4 times negative 3 is negative 12. Alright, now we're going to do negative 3 times 2 squared. Well, 2 squared is 4. 4 times negative 3 is also negative 12. So let's compare. Negative 12 is equal to, less than, or greater than negative 12. It's equal to. Alright, let's look at, well, we already know that if I plug in negative 2, I get negative 12. That was the same as that. Let's plug in 5. So negative 3 times 5 squared is negative 3 times 25. Negative 3 times 25 is negative 75. Is negative 12 equal to negative 75? Less than negative 75 or greater than negative 75? Negative 12 is greater than negative 75. So they're giving you x values, you plug them in. You are comparing y values when you do this. Now, I love tables because tables we don't have to work for. We did a lot of work in that one. This one, we don't have to do as much work. Here, remember, these are x's. What is the y? Here's the y. What is the x? So, if I look in the x row, and I look at negative 1 is paired up with a y value of 7. If I look for x is 2, 2 is paired up with 6 in the y. Now, you may not think of it like this, but h of x could be replaced with y. It's just a fancy way to write it. So when y is 1, well, y is 1 here, the x value that goes with it is 0. When the y value is 0, the x value that goes with it is 4. So again, you're learning how to read these. You're learning what is expected. If they give you one thing, where do you go to look for the other? So let's look. When they say h of 2, the y value is 6. H of negative 1, the y value is 7. 6 is less than